Related to Robot Studio, there are lots of things related to that one that can be done, and this is just a short reflection related to the last exercise. But just a comment about Robot Studio, it can be quite complex and complicated, as one might expect. So there are add-ins available and API available. So it's possible to actually do any kind of integration. And in that respect, for example, make integration to models made in CAD systems or similar. And also during the simulation, I can quite easily create stuff along the way. For example, during an assembly simulation, you want to actually create stuff, CAD objects along the way, and when it is assembled, those should be taken out of the system. Those things can be quite easily made. You can also add sensors, for example, or kind of model a system that includes sensor and react to that kind of behavior. And it would also be able to have a mixed mode where input comes from real sensors, hardware, into the simulator. So it would be kind of an augmented reality type of application. But there is always a but. The more complex you make the simulation, the more time it will take. And in most cases, there is always a trade-off between the time taken to do the simulation, the level of accuracy you attain, and when the simulation is needed. So in most cases in manufacturing, the simulation is needed quite soon, sometimes yesterday. So the final decision about how accurate and how good looking the simulation is in a way and accurate to the reality is usually to do with kind of a quick and dirty, as quick as possible and as accurate as is needed. So that is the problem in general. There is also a link to virtual reality. I think some of you notice it. So you can connect, for example, an Oculus head-up display to this one and get the sort of augmented reality, realistic view about this. They have implemented an application related to spray painting that actually works quite well. And it is said that from users that the programming time in spray painting operation goes down a factor of, from if it takes 5 days, it can be done in 1 or 2 days, the same type of programming. So that is quite drastic. Anyway, just a tweak about the last exercise. If you choose to do it as building a tower instead, that can easily be done. Something like this. Sorry, this was actually what we done in the exercise, right? So we have to run the right program instead. Just stop it there. Reset it. So if we then run it with a edited and change program actually in the rapid code, it might look like this instead. So instead of moving from one pattern to the other one, we put it on top of each other like that, and it looks beautiful and perfect. But then if you verify it in reality, it might be not that easy, because the higher you make it, you sort of add errors in related to the tolerances. The cubes have some specific Yeah, you sort of assemble it to tower, but there are some tolerances when you mount it within a few tenths of a millimeter, and that might add some deflections around this one that is not so nice, really. So if one run that, it will look something like this in reality. Okay, so something like this um, is how it runs in reality. And well, I run it pretty slow now on the robot, but anyway, it will be the same rapid program as you saw in the simulation. And adding 1, 2, 3, 4 is not a big problem. The tolerances is roughly, I think it's 1 or 2 tenths of a millimeter around the cubes, but those add for each one, and eventually you run it, and eventually, especially if you run it fast, there will be sort of collisions on the way. So now we put number 4 in place. I'm standing, sort of say, standby here, or able to stop it whenever it needed. You see, here it was almost not able to put it in place. It was touching, so to say. Now we have number 5. So it's really touching. If you run it really fast, it would not be so nice. And now this is number 6. So it really doesn't work in a proper way. Just correct that. And number 7. Yeah, almost did it. But it made it by chance, I would say. Number 8. And finally, number 9. Like that. Okay, we stop that now. So that is really the challenge. One have to really make sure and validate and also validate that things are going in the right direction as expected. We're doing the right thing, but verify also that it really works in real systems, say, whenever that is possible. Or if we have the knowledge, understand that it is not maybe. So if we then go back here, we just in cessation, and then we we go to the rapid code, and actually what happens here is that the the procedure palette has to be rewritten in a way that instead of moving as we did before, we now move in the set direction instead. So that is actually the only thing that we changed. And then one has to do a few more things, like introduce a Z counter that counts the number we are actually adding. Then when we do these kind of things, one has to be careful, because if we run this software or this program in an autonomous mode, we have to be aware about when we repeat this. So this set counter counts to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it doesn't reset. So one has to be careful to, in the end, reset counters when we redo the whole operation, like a finishing procedure or whatever, to finish up and clean up everything, and then we can make it again. That is one thing that is quite important. Um, Otherwise, it's pretty much the same. We have the pallet pods, which is the post of the cube to be picked, and we have, and that is calculated here. We have the place pose, which is an offset from the grip pose. We move it 300 millimeter in Y direction, and we move it upwards the set counter times 40 millimeter, which is the dimension of the cube. And the set counter is added for each time we run this procedure. Then we move and to the pallet pose, fine position. We grab that one, wait a little bit, and then we move upwards a little faster, and to the place pose, and above the place pose actually, then we move to the place pose, open the gripper, wait a little, and then we move up a little bit and offset to the side, add the set counter, and then that can. So in that way it works pretty nice. But what we have to remember is that such things has to be checked. Does it really work in reality? And then, of course, there are many other things to do in Robot Studio related to integration and that sort of thing. And one can also make simulations and rapid programs that add to the user interface. So we can actually program user interface stuff related to the teach pendant, and things can be added to that. So the operator only sees action buttons to do run program 1, 2, 3, whatever, and do that only, and doesn't see any software running. Okay, I think that's all.